Alright, in this next example we're going to graph a tangent function. I put the formula underneath it so that you can look at it to compare, and also the period is different on a tangent and cotangent. Remember, the period is a pi, so make sure you are careful there. So go ahead and determine your amplitude, or in this case it's not necessarily an amplitude, but determine your a value for a tangent function, your period, and your phase shift. Okay, good. So your a is 2, your period is pi over 2, and your phase shift is pi over 2. Now, remember we're going to do this a little bit different. For the tangents, we're going to use the method that we learned in our previous lesson. So the first thing we want to do is find the asymptotes. Okay, so to find the asymptotes, we need to know where it's undefined, and we'll make a note over here that tangent, the graph of tangent, is undefined at negative pi over 2 and pi over 2. That's whenever you have tangents, your sine over your cosine, and that's when you get 0 in the denominator. So that occurs at negative pi over 2 and pi over 2. So to find our asymptotes, we take our parenthesis portion of our function, because that's what's going on. That's where the change in the shifting's going. So we take that portion, 2x minus pi, the part that's in parentheses, and we set it equal to negative pi over 2. And we also take that portion in parentheses and set it equal to pi over 2 to find our two asymptotes, because this is where the shifting and moving's going on. So we got to see where these asymptotes move to for this graph that's not a parent graph. And so now we're just going to do the algebra right here. So let's come here and multiply this side by 2. If I multiply that side by 2, I'm going to multiply this side by 2, right? So then this would cancel, and then I would distribute over here, and I would get 2 times 2 is 4x minus 2 pi. So we want to distribute over here. And then what are we left with on the right? Just minus pi, right? Or negative pi. All right, we want to solve for x, so we're moving 2 pi over. So you get 4x is equal to pi. And solving for x, we are going to divide both sides by 4. So we find out one asymptote is at x equals pi fourths. Okay, let's come over here to the right and do the same thing. Multiply both sides by 2. That means these 2's would cancel. 2 times 2 is 4x minus 2 pi is equal to pi. We're going to move 2 pi to the other side, so add 2 pi. Always looking for x in this case, trying to find out our new asymptote. Then lastly, divide by 4. So the asymptotes for this particular graph of y equals 2tan of 2x minus pi are going to be here and here. So our graph's undefined at these 2 points. Okay, so basically this is what we have set up. Move this out the way, where we're undefined at pi fourths and undefined at 3 pi fourths. We need equal increments to get to these other x values. So we could take our period and divide by 4 to get these other ones. So I want you to pause the video and do that. We can see that we have pi eighth increments, so now add pi eighths to this, so on and so forth till you get all of your x values. Okay, so pi fourths, 3 pi eighths, pi halves, 5 pi eighths, 3 pi fourths. Alright, let's set up a table on the next page. Okay, so take and check your table to see if you set it up correctly. We don't have to do the work on these undefineds because we found our asymptotes earlier, so really we only need to calculate our 3 points in the middle. So pause it until you have all this, and then you can try your answers and see. I'm going to work through a couple of them with you. So first of all, let's simplify this. So we will have 2 times the tangent. 2 times 3 is 6 pi over 8. 6 pi over 8 is just simplifies to 3 pi over 4 minus pi. Okay, so we're still going to do some work on that parenthesis. Get a common denominator of a 4, and then when we subtract it, we get negative pi fourths. Okay. Okay, so we can either find coterminal and find the location for that, or we can go, remember we're going to have to start here, and it's a negative angle, so if pi over 4 is positive up here, the negative pi over 4 is going to be this value right here, okay? And tangent is going to be your y over your x. So what's negative square root of 2 over 2 divided by that? Well, anything divided by itself is just going to be a 1, but this one's a negative. What's a negative divided by a positive? Negative 1. So that seemed a little bit complicated, but just take your time, and that's just going to give you a negative 1. Okay? Well, I mean, negative 1 is our value. Sorry. And then we would just get 2 times negative 1 is negative 2. So the ordered pair would be when x is 3 pi over 8, y is negative 2. Let me move that. Now let's look at the next one. So the 2's will cancel, so that's nice. So we're just going to have pi minus pi. So we'll have 2 times the tangent of 0. Okay. 0 here, what's the y over the x? 0 over 1 is okay. 0 divided by 1 is just 0. So that would just be 2 times 0, which is 0. X value would be pi halves, comma 0. Alright, let's go do this one now. 2 times the tangent. 2 times 5 is 10 over 8. If you simplify that, 10 over 8 and reduce it, that would just give me 5 pi over 4. So 2 times the tangent. 5 pi over 4 minus pi, get a common denominator of a 4, and then simplify that. That would just give us pi fourths. Okay, let's go to the unit circle. Tangent at pi fourths. So we come here to pi fourths, and your tangent is going to be your y value over your x value. Well, these are the same, so that's nice because it's just going to simplify to what? Positive 1. Good. So 2 times 1, which is 2, that would give us the ordered pair 5 pi over 8. Let me fix that. 5 pi over 8 and 2. Okay, so on the next page we're going to sketch the graph of this thing. Okay, so we have our vertical asymptotes at pi fourths and 3 pi fourths, so sketch those in. We reminded ourselves of our ordered pairs. 3 pi eighths, negative 2, pi, 0, 5 pi eighths 2, and we remember that parent graph of tangent increases to the right. Okay, so there's your rough sketch. Okay, here's going to be our next example, but we're going to heavily use our information for graphing y equals sine of x since it's the reciprocal of this one. So we're going to do that, and we're not going to work out the whole xy table. We're just going to give you the basic information that you're going to need to get a rough sketch of this. Okay, so I'm just going to rewrite this as a sine graph function. We determined our A, we determined our period and our phase shift, and this is just showing the calculations here. So we're going to use this information to get a rough sketch of our sine graph and then use that to graph this. Okay, we start with our phase shift, add our period to get our endpoint. So basically we know our starting point and we know our ending point. So on this next page, I don't have it to scale, but I have just the starting point, equal increments, and an ending point. I also have my, let me remind myself, y equals this is what we want the graph of, but we are using y equals to sine of this function to help us plot that. Now we know the sine, a parent graph for a sine function looks like this. Right? Okay. Well, that's all we need to be able to do that. For cosec, and we know it's going to be undefined here at the values. So it's going to be undefined here at pi over 24. Pretend that's over there. And here, everywhere it crosses the zeros. So here, here, and here. So I'm going to try to get it on the mark, but I'm off. You can see. A little bit hard to get those on there. And then here. Okay, so everywhere it crosses that zero, the sine graph, we're going to have undefined, and then we're going to graph this in blue. So y equals 2 cosecant x. We're just going to come here and sketch these as if this was like points right there, and rough sketch here. So y equals 2 cosecant 4x minus pi over 6 is going to be the graph in blue. But you could see how we used our sine graph to be able to get that sketch.